All right, so today we're going to talk about how we actually measure biodiversity. So we've spoken about sort of what biodiversity means and different things that you can look at in terms of, species richness and relative species abundance, and the number of endemic species. So those are different criteria you might look at when you're trying to decide how biodiverse an area is. But there is actually a quantifiable way that we can do this, and this is this equation that I was talking about, and it's the diversity index. So diversity index is a way of measuring the biodiversity of a habitat, taking into account the species richness and abundance. So remember we said, there was a difference between richness, so how many different species there were, and abundance, so how many there were of each type of species. So your equation is this, so D, which is your diversity index, equals the total number of organisms of all species times total number of organisms of all species minus 1, divided by the sum of the total number of organisms of each individual species times the total number of organisms of each individual species minus 1. Okay, we're going to do a couple of examples, and I promise you once you've done that, it's going to make way more sense than what it does right now. Big takeaway from this particular piece of paper, write that equation down, write down what each of them means. Okay, and the higher your biodiversity index, the better. So you're going to get a number, obviously, at the end of this, and the higher that number, that means you've got a higher biodiversity index, and it means that the area, the habitat that you're looking at is more biodiverse. Okay, I'm going to go through an example with you now. This is the example that's the worked example in the textbook. Okay, so if you can't read my handwriting or anything like that, or you want to look at it, printed as opposed to me writing through it, then it is there on page 270. Okay, but here is, whoops, if I could get the clip on. There we go, sorry about that. Here is our example. So as you can see, I've got our species down the left-hand side. So this is looking at a pond, okay, but you could do it in any sort of habitat. And then I've got the numbers of each organism collected. So there were 4 dragonfly larvae, 12 mosquito larvae, etc., etc. Okay, my capital N in my equation is really easy. It's just the sum of all of these numbers, which I can tell you is 40. Okay, so I've already worked out what my capital N is, so I can start to fill in my equation here. N minus 1, so 40 minus 1 is 39. I'm sure I don't need to tell you. And then I've got to do this, my N, times my N minus 1. So 40 times 39, which equals 1,560. Okay, so if we look at my equation, my top number is going to be 1,560. Okay, I've got to work out what the rest is going to be now. And so how you do that, again, if you've got your table set up, it's going to make your life a lot easier. First of all, I've got to do my N minus 1s. So that's what I'm going to fill in all here. We're done with this row at the bottom now, so we can now ignore that. So 4 minus 1 is 3, so on and so forth, till I've completed all of those. So that's my N minus 1 column. So that's this bit here dealt with. I now need to times this N minus 1 by my N. So I'm going to do my 4 times 3, which is 12. And then obviously work my way down doing the rest of them. So 132, 6, 12, and 272. Okay, so now I've got all of my lowercase n's times my N minus 1's calculated. So now I've got to figure out the sum of those. So I've just got to add up all of those numbers. So again, we're ignoring this row down here, but I need to add 12, 132, 6, 12 again, and 272. Add up all of those. And I can tell you that answer is 434. All right, so now I need to do 1,560 divided by 434, which equals 3.60. Okay, so that would be your diversity or biodiversity index for that particular habitat. Okay, so 3.6, relatively high, so it's a relatively biodiverse area. All right, now I'm going to ask you to do one for yourselves. I haven't named these species, I've just called them A, B, C, D and E, but I'd like you to do the exact same thing for yourself. Pause the video and draw out your table. Give yourself, a few minutes to complete it and then come back to me. So what are the following number of, there are the following number of species in an ecosystem Calculate the biodiversity index, set up your calculation in a table and show all working out. Species A equals 10, species B equals 18, species C equals 16, D equals 2, and E equals 8. So pause me now, draw out your table, start playing the video again once you have completed it. Okay, so hopefully you have completed your table now and you have an answer that looks something similar to this. So remember these numbers here, this lowercase n number of organisms collected, those are just the numbers you were given in the question, okay? I haven't pulled them from anywhere else or made them up, that's where those have come from. My capital N is those all added up, so that is 54. Capital N minus 1 is 53. Those two numbers timed together give us 2,862. So that's our top number in our equation. That's our n times n minus 1. Okay, and then we can now ignore that row, pretend it doesn't exist anymore. And now I've got my lowercase n minus 1s to calculate. So that's all I've done here is take away 1 from every single one of these numbers. And then you've got to do the original lowercase n times your n minus 1s. So 10 times 9 is 90, 18 times 70 is 306, all the way down. Finally, I've got to add those up to give my sum. Okay, so when I add all of those up, I should get 694, which I will just fill in there for you, or you should have got 694. So then I'm finally going to do 2,862 divided by 694 to give me an answer of 4.12. Possibly 4. You can leave it as a decimal. I just rounded it out of habit, to be perfectly honest with you. But yeah, you can leave it as a 4.12. So this particular habitat has a higher biodiversity index than the previous one, but both of them are still relatively high. Okay, if there's anything you're not sure of on these, please have another look. If it still doesn't make sense, let me know, and I'll see if I can find you some more examples to work through. Okay, but for the length of the video, I'm just going to move on now. So a few reminders about sort of biodiversity and what we're talking about and what might affect it. So in the last lesson, you saw that high biodiversity is seen in ecosystems that meet different kind of criteria. The first of which is when their ecosystem is very stable. All right, so extreme environmental conditions, think like a desert, but that's not the only example. It could be, you know, somewhere Arctic, for example. The biodiversity tends to be low because any change in this extreme environment has a big change in population numbers. Okay, so anything that happens in this environment could wipe out your population really, really easily and affect your biodiversity. So because of this type of ecosystem tends to be unstable and very susceptible to change. So things like drought, flood, not for a desert obviously, but other conditions, a frost or the introduction of a new pathogen can completely change that ecosystem and alter it. These ecosystems also tend to have unfilled niches, so unfilled roles within the ecosystem. So any incoming organism that's new to that ecosystem can become established very rapidly and overpower an existing species. So essentially, in these extreme environments like a desert, they're really unstable. Okay, they're susceptible to changes, they're susceptible to new organisms, they're susceptible to new pathogens. And so because of that, you don't have a high biodiversity. There's too much instability. Whereas in less hostile environments, biodiversity can be very high because you have a stable ecosystem. All right, so where you don't have these issues, biodiversity is much more likely to be higher. Biodiversity can be lost due to natural events, so things like those floods, those frosts, those droughts, you know, volcano eruptions, or there is also obviously the impact of human activity. Small or isolated ecosystems, so think like islands in the middle of the ocean, not near any sort of other land masses, they're going to be an example of an isolated ecosystem. Those are your most vulnerable to damage and destruction. If these areas are biodiversity hotspots, there is a higher risk of a loss of biodiversity because obviously there's more biodiversity there in the first place. So all of this means really that it's really important that we do measure and regularly keep an eye on biodiversity so that we know what's happening and we can try to put measures in place to stop this loss. Now, I've said it's important that we measure biodiversity. It's worth noting that actually biodiversity is not constant and can vary with the time of day or even the season. So whilst it's important that we are aware of the biodiversity of a particular area, it's worth realising that just because in December the biodiversity is low doesn't mean that something bad has happened. It just might mean that in that particular season there are fewer animals there because they've gone to warmer climates, for example. So you just need to have in your mind that just because you've calculated the biodiversity index of an area once, that doesn't mean it's like that every single day of the year and every single season. Okay, it can be slightly more fluid. So biodiversity within a species is really important. So there's just kind of a key sort of definition that you guys need to know first before we can carry on further, and that is the idea of what a gene pool is. So a gene pool is all of the genes in the genome, including all of the different variants of each gene. So it's kind of like the bank where the genes can be selected from. And mutations can increase the gene pool of a population by increasing the number of different alleles available. So if you imagine you've got a mutation, whereas before there was only 2 alleles, white fur or black fur, say, there could be a mutation that suddenly crops up, I don't know, grey fur, okay? So as you can see, you've increased the number of alleles available, so therefore you've increased the gene pool. Now, those mutations can obviously either be advantageous or disadvantageous. The ones that are advantageous will typically be selected, so that allele will be the one that's chosen, and so that allele frequency will increase. It will be present in more organisms within a population because it's an advantage. Whereas if it is disadvantageous, so it's something that's bad, natural selection may result in its removal from the gene pool. So those organisms are probably more likely to die, so are less likely to breed, therefore less likely to pass that mutated allele on. But what happens more often than not is that actually the allele is retained, but just at a very low frequency. So it's quite rare to wipe out an allele from a population. It's more likely that it's just there, but at a very low frequency and a very low presence. However, you guys need to remember that we might label an allele as an advantage or a disadvantage, but actually what mutation is advantageous and which one is disadvantageous can change as the environment changes. So it might be that originally, you're an organism that lives in an Arctic climate, so it's advantageous to have a white fur colour. But if the climate changes completely and there's no longer any snow, then having a white fur colour is no longer an advantage. It's just going to make you stick out. And so these changes in allele frequencies due to natural selection can actually result in a new species developing. Now, genetic variation within a population is an important of biological health. Without variation, a population is vulnerable. If you think if all the organisms in a population are genetically identical as each other, that means that if the environment changes, they could all be wiped out. If there's a new disease, they could all be wiped out. So you need to have some genetic variation within a population to ensure the survival of the species. So the way that scientists measure this is with a heterozygosity index. And so again, it's worth knowing this calculation. You might be asked to use it in sort of an exam question situation. And to work out your heterozygosity index, you just take the number of heterozygotes. So remember, that's the organisms that have 2 different copies of the allele, and then you divide it by the total numbers of individuals in a population. And a high index indicates a high level of genetic variation and a healthy population. So again, you want a high number for your heterozygosity index. You don't want a low number. Low index indicates the opposite. So there's a low level of genetic variation, potentially an unhealthy population that are going to be susceptible to changes in their environment. Okay, I need to talk to you guys about Hawaii and how it's an example, but I'm running out of time on this video. So please look at part 2 for the last little bit of the presentation.